Hi and welcome to my playhouse. And today we're not doing much. We're just messing around with batteries and playing with power. On the table here, let me just mention that it's almost Christmas. It's the 22nd of December. I was, soldering up my hopefully close to 1 kilowatt hour battery pack full of 18650s. Where when I thought that I better reach the camera and show you that I was doing that. But also in here, in the creepiness of the basement, I'm playing with the big pack. I have some more lights up here. I've actually mounted some LEDs up here just to give you some more light when I'm filming in here. So that's for that purpose entirely. And over here I have the UPS standing or mounted, and right now it's running, and I was kind of testing it out to see how it was doing, and just to test it out with something meaningful, I have it on this charger is charging that battery from all of these batteries. As you might remember, I have 12 batteries over here and I have 12 batteries over here, so something like 24 kilowatt hour of battery stored. And up here, if we can communicate with this thing, we will be able to see the battery power. It's dark outside, there is not coming any power in, but the battery voltage is 51.2 volts. And we could just check this, see how much power that drains. There, amperage. Zero that out. There, 0. We can put that there, and we can see that it's drawing 1.67 amps ish. The battery down here has been on the charger for quite a while, so I'm guessing that it's full. So we could try and take another one over here from the stack of batteries that I thought that I was gonna be building this system with all old batteries like this, but then suddenly these came along, and now I'm not totally sure what to do with all those old batteries. So I disconnected the battery that had been charging there for a couple of hours. So we're gonna hook the next one up. You can see right now it's not charging with anything. We could just check. It's drawing 1.25 amp ish without anything going on. So let's hook this up. And it pulls about 2 amps down here. And it pulls about 2.1-ish amps here too. So now we're charging that for a little bit. So that is what's going on in here. In my last video where I connected this, I had the problem of it beeping, and someone helped me in the comments by saying that when it beeped, I just had to press the on button and it would shut off the beep. And surely enough, that just killed that. That was cool. So very nice. Also, someone very wise said that I could just have exchanged the blue plastic here with a piece of gray plastic and everything would have been good. And yes, that would have worked just fine. I didn't think of that. Okay, so but in here again, I'm mounting this BMS on the battery. What this does is that it makes sure that all the battery packs, this big battery block contains of 14 individual packs of cells. Like there are 10 cells that are turning one way, and they are serially connected with the next pair. So there are 14 different blocks of batteries up here. It's a 14 pack, and this BMS can supply 15 amps. I am hoping to stay way below 15 amps. I rather want another one and not overdo it. if you run it to the max capacity of a bank like this, well, you don't get the full power out of it. So it's better to run them below what they can handle. So yeah, let's just see what I've been doing. I have completed one side. As the battery goes this way and this way and this way and this way, I have connected the BMS. Half of the leads go over this way and the other half of the leads go over this way. And there are 15 leads that goes on to every connecting point of the battery here. So let's check this out. Here we are. So I have the leads from the BMS coming out here. It looks pretty cool. It's okay. All the fuses looks still to be good. And I have done this side, so I was just about to complete the other side when I thought, well, I might as well show what I'm doing. I use a piece of this plasticky thing to lay them down on, so that they kind of are laying there softly. So I have this wire, and I'm connecting this wire to this group of batteries. It's where two packs, well, they meet. So over here we have the plus side, and over here we have the minus side, and we want the BMS to be able to measure that voltage that is happening there. Or measure, it's just evening out the voltage there. I just want that to go down here and be connected there. So we will shorten this quite a bit. So we'll do that. Make sure that I haven't done anything stupid first. There. Sure. I have a thingy thing to uninsulate that. I think it's kind of brilliant. It clamps on. We could do a test. We have a piece of wire here. So what it does, it holds on to the wire, and then it pulls these back and remove the insulation. So cool. So soldering iron here. We have some tin. And we'll just give it a bit here on the wire. I have put plastic on here, tape, to make sure that I don't short circuit anything too important. So I'm gonna pull that back a little bit, and also here, there, and we're gonna solder that down there. Ow, 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 ow. Ugh. There. And that's just one more done. So I'll do the next one. You don't have to wait. Okay, I'm gonna try and explain how this BMS 14S works. 14S, that's the number of cells, the number of batteries in series. And we have, each of these are 10 batteries, and then 10 batteries in parallel here, 10 batteries in parallel, and then all of those are in series. And the BMS is to control all of that, because if this battery comes out of, if the voltage is lower here than on all of the other ones, well, the whole battery hurts under that. So it's very important. If this is lower, well, then it will lower the rest of the battery and charge everything up so that everything is the same. I have sorted in these connections. These are the thin wires, and these are more or less, they're the balancing leads, and they're kind of the sensoring tools. They can go out and check if this voltage is higher than this voltage. I think I did that wrong. I was just watching a video on that, and the very first thing they said was that you should connect everything else before you connected this. So I might have wasted my BMS already, but well, we'll check that later. But the BMS is here to protect the system. It when you are charging your battery out here, the BMS will make sure that you are not doing anything wrong. If something goes wrong, it will disconnect, and hopefully that should do so that you don't damage anything. And it does that by disconnecting down here. And I haven't drawn up everything. These are a representation of my solar panels. And the solar panels, when I want to charge the BMS, I will of course have a solar panel system. They will include a charge controller. I'm just gonna say that we have a battery here. We have a plus and a minus, which represent the solar panels. So that plus will go to the plus of the battery over here. The minus, on the other hand, that will go to the BMS, so that the BMS will be in control. Down here there's the world's most ugly light ball ever. I made that myself. It doesn't look like a light ball at all, but it is a light ball. It has a negative side and a positive side, so it's probably more of an LED, but well, never mind. So we will hook up the positive side as well here. So this is our load, and the load, well, it's connected to the same place. Here, the plus side, that's a connector. So whenever we want to charge the system, it's from directly to the plus side of the battery, and whenever we want to use it, it's also on the plus side of the battery. Then we have the negative side of the battery here, and the negative goes over to the BMS, and it goes up to this B minus that is it's on the circuit board of the BMS. And that's the way that the BMS controls it. It's able to shut that off if something bad happens. If we're charging the battery and the battery reaches critical high level, well, the BMS will shut that off and say, well, we are fully charged, we can't take any more. So it will cut that connection. That also means that this C connection here, that goes out to first, it goes up to our charger, solar panels, and it also goes down to our light bulb there. So from this connector and from the plus side of the batteries, we are able to either charge the battery or discharge the battery, use the power. And the BMS is in control in between by disconnecting the negative lead here if something weird goes on. So hopefully that is what I'm doing. That's gonna be exciting. If that made no sense whatsoever, well, welcome to the club. So that's what we've done here. I have mounted a little bit thicker wires here. This one is rated for 15 amps. So as long as I stay way below 15 amps, it's all good. So I have a 15 amp wire going in here and to the B minus connector, which corresponds with my drawing here. The minus lead of the battery goes up to the B minus, and the drawing is actually also on the BMS here, so I have been trying to copy that. The Chinese lettering on there makes that a bit difficult, but I am guessing that one of these are the charger and one of these are the load, and that's what they're trying to tell me there. I did also go up and find some additional information. I think this is good, I hope. Otherwise, well, let it burn. So the negative lead from the battery goes in here, and the negative lead for usage and charging goes out here. And it meets up down here with the positive lead, which is soldered directly on the batteries here. So I get this kind of a configuration. It's really simple, just two wires, and we have a battery. I really want to put some connections on here, so I have already gone and ordered those, and I've ordered some. It's not exactly like this, but a similar system like this connector. Bigger connectors, but similar. You can see that they're out of, you can't turn them around or do anything stupid. You can just plug them in and they're plugged in. So I'm getting some of those thicker and bigger wiring, but well, I think this is good, and I hope that I'll be able to measure the right voltage right there. So we'll try, and I disconnected this when I saw that video where they told me that I was doing everything wrong and that I might have killed the BMS by connecting it in the wrong order. Well, let's see what happens. If it's dead, it's dead, and we'll go order a new one, but that's another month. Let's plug it in. Yeah, I would actually like to measure and see if the voltage is good there. I think we'll try that. Can we do that? So if we put the positive lead on here and the negative lead on there, we measure 56.8, 52, 48, 44, 40, 36, 32, 28, 24, 20, 16, 12, 8, 4. Okay, that looks about right. Everything should be good. I should be able to have the right voltage out there then. So let's uninsulate these. I'm taking off as little as possible, just in the event that something bad should happen. So let's see. We did just measure that 56 voltage, so if this is working, we should see that again. Yeah, 56.8 volts. Okay, so we could try and charge that a little bit. I have two power supplies over here, and they can combine, they can do 60 something volts. Okay, I've connected my two power supplies in series. The top one is only good for an amp. The bottom one is good for 5 amps, but when they are in series, the loser wins. So this is 66.7 volts, about 1 amp. So let's try and connect that up. We'll push this on the plus lead. Oh, let's have the voltage there as well. There. I don't like these wires so close. And the negative lead here. Oh, it charges with an amp. The voltage went up to 57 or went down to 57.2 volts. And the top power supply over here, it has a red light on here. This means that it's using all the amps. So right now I'm charging the battery through the BMS. That's nice. Still 57.6 volts. I just went up and calculated that if every cell should charge up to 4.2 volts, well, that would be 58.8 volts. So it's good. I wanted to measure the current that goes into here. So we're gonna set that to amps and zero that out and check if we see 1 amp going into the batteries. Minus 1 amp. Weird. Am I measuring this wrong? Okay, so if it goes that way, it's plus 1 amp. Okay, so it's just me learning to use this. Cool. I've been looking around. I don't really have anything that uses 48 volts or 57 volts that I can plug in and see this being drained. That's a bit of a problem. Okay, this is pretty awesome. I have already charged the battery up 0.1 volts. Oh, 0.2 volts, so awesome. I was intentionally hoping to use this Chinese cheapo charge controller, but it seems that it's not able to handle the 110 volts coming in from the solar panels and stepping that down. So I'll have to go and find another charge controller to charge up the lithium ion bank here. Unfortunately, this one will just not cut it. But well, I got a bit further on this project, and I do really hope that everybody is enjoying their holidays. We are celebrating Christmas here, and thank you very much for watching my videos. Do subscribe to my channel so that you can see me again, and have a really nice day. Bye bye!